Okay, hopefully the audio works. I'm not quite sure if it does, but I'm Eridani Rojas, and I did my presentation on gold in our lives. So let's go on with the slideshow. Okay, so the atomic information and properties. So it's number 79 on the periodic table of elements, and that's because it has 79 protons, 79 electrons, and the atomic weight will equal around 197. So it's got 118 neutrons to add on to that weight, and the electrons barely count as weight. But some of its properties are it has a very high corrosion resistance, so that's really good for batteries. It's highly conductive of electricity. It's that goes to show for like electronics. It's incredibly malleable, so you can mold it into whatever you want. Well, almost anything you want. You just have to apply enough heat and pressure, and then it'll start moving around. And it has like really high ductility. It has a high heat conductivity, so it has a really high melting point. So that's really good for electronics because electronics have motors, and they tend to get pretty hot sometimes, especially if you leave them out in the sun. And some electronics just simply won't go out because they have that strong gold. But that depends on the quality of phone you might have. So how it's mined and where primarily. So there's four methods to mining gold. There's placer mining, open pit mining, byproduct mining, and ore processing. So placer mining is like the old-fashioned way. It's like you imagine like a California gold rush guy, just like getting like the pan and just panning it out. Well, it's basically that, but it's evolved to more like a civilian way with something called a cradle, and then they'll use water with this cradle and they'll put dirt inside of that cradle and they'll shake it out and they'll sift out the gold using the water. So it's like a sifter for gold. So that's how you and me could basically go gold mining. But a more industrial way would be open pit mining and byproduct mining and ore processing, which we'll talk about. So open pit mining and byproduct mining are essentially the same thing. Open pit mining is specifically for gold, and not only gold, but like it's specifically that's what they're looking for. So open pit mining is basically you have a big giant machines and you have a big giant cave, and then you got big giant machines that want to get into this big giant cave, and they're gonna basically dig out these rocks and they're gonna take them out and they're gonna crush them, and then they're gonna basically sift out the gold in that material, and they can create a lot of gold from this. But the thing is, they can create a lot of gold from byproduct mining as well, because in India, byproduct mining actually yields quite a bit of gold, and it yields more than like gold focused mining industries, which is pretty funny. And then to a least efficient method, like even like less efficient than placer mining because of the cost, ore processing. Ore processing is very expensive. It's straight to the point though. You grab an ore where the gold may be, and then you just simply process the gold out of it. You put it in this machine, and this machine will basically make it react to gold and specifically gold, and then the gold will be poured out onto this little like cup, and then that's where they get the gold basically. But it's so expensive, and it kind of there's like no point because if you already got the ore, you might as well just crush it and do the old-fashioned like sift methods, put it through a couple machines and yeah, and purify it. But yeah, China is the #1 gold producer in the entire world. So this was recorded in 2020 when it was on its gold production, but in 2020, which is last year, it was the #1 gold producer. I thought it would be Africa, so I thought this is very interesting, but Africa is like third or second place. And then it comes along the rest of Asia. So the uses, there's actually a lot of uses for gold, like a ton. So the main things that it's used for, I would say, is automotive, electronics, dentistry, and aerospace, especially aerospace. So in the automotive world, you have a high corrosion resistance with the batteries, right? So this is really good because anytime you're working with batteries, you know, that lithium, it starts like to corrode on anything, right? You got gold that has that really high corrosion resistance, and it just doesn't create that problem because like when you have something that corrodes, you impact its like electrical conductivity. And then when that happens, you have a electronic that just doesn't function anymore. But even then, our car batteries do still corrode, but it's more on like the more specific things that it won't corrode. So then we go on to the RBC, the Royal Bank in Toronto, Canada. I decided to include this because they actually gold plated all of their windows, 14,000 windows actually. And they did that because of the installation power, I guess, that gold has. And it was able to reduce their AC bill by, I don't know how much that, it wasn't disclosed, but it was able to reduce their AC bill by quite a bit. And it was a worthy investment in the long run, but probably not when they like did it. So I thought that was really cool. And then the aerospace industry, I mean, it's pretty much the same thing as like the automotive industry. Is like there's like the batteries and a lot of electronics that go into it, and you don't want any electronic in mid-air or mid-space to like corrode and die on you. You do not want that, because if that happens, or like the plane won't start, or the plane just stops working all of a sudden, what then, right? Like somebody's gonna die. So then we go on to dental and dentistry. And the reason why it's in dentistry is because it has a really, not high, but it has a low bacterial gathering rate compared to like other transition metals, which is why it's selected. But not just that, gold is also very biocompatible. And because it's so biocompatible, it's able to be molded like that. And it's able to be safe for the mouth too, because you can't just put anything in your mouth. So they use gold with another metal, and they create an alloy, a dental alloy, to basically have this like crown in your mouth that's non-infectious, and that still like doesn't hurt you, and that still is like, it's like comfortable, and it does its job. And it's really cool. It's really cool how they were able to incorporate like just gold into literally your mouth. But yeah, that's why like when you go to the dentist, sometimes you'll leave with a really big bill, especially if you got like crowns done or like even braces. So that's the reason why. That's the reason why your dentist appointment might cost a lot. And then we go into electronics. And electronics, I mean, it's pretty straightforward. I mean, it's super malleable, super conductive, high heat resistance, high corrosion resistance. Like it's all the good things you ever want. Electronics is like the foreman of gold in its uses. 100% electronics, besides jewelry, but I'm talking about practical purposes here. And speaking of impractical, we have food. People actually put people actually put gold flakes in their food. And what this does is absolutely nothing. It actually is just like a traditional way to display your wealth. So, and because it's so biocompatible and it's safe for your body, it doesn't do any harm to you. It's like just adding money, because I guess it's expensive, so you might as well drink it. So that's why it's used in very few foods and very few drinks. It's more like it's tasteless. It's more like a dress up thing. And recycling. Now this part is actually really interesting, because recycling gold is probably like the best thing we could ever do. However, there's one ultimate like downside. When gold is not very easy to recycle, because you need to have specific things. So what they use to recycle gold from electronics, let's say, would be like they would grab this like compound, and then this compound would basically stick to like any surface that you attach onto it, and then this compound has this like this reaction with strictly gold, and then it'll peel the gold off, and it'll leave all the other materials on like say like a battery chip, or like not a battery chip, like a computer chip, or like a motherboard for like a phone. It'll peel all the gold off, and it'll react only with the gold. So that's pretty cool, but it's not kind of expensive, but it's like not costly. It's just when you have a giant landfill in, let's say like India or Africa, that's not really available on hand. You kind of have to like strip it. But another thing, you could also like burn stuff, but I don't think that's really helpful. But the reason why it's so dangerous is because it's an environmental hazard to recycle gold, like the old landfill way. The landfill, there's a computer, and we're gonna throw it in there, then we're gonna recycle the gold out of it, because why not, right? Well, when you have that, you cause a lot of environment damage, and then that's why landfills usually there's there's no grass like at all, and then the pollution is like absolutely insane. I think we watched a video in class on it. It was really interesting. But that's kind of what inspired me to do this, like this topic specifically, was because I thought it was interesting and I wanted to know how gold specifically was recycled. But yeah, recycling gold is like amazing because let's say I have gold from like a billion years ago. I mean, not literally, but like let's say I do, and I were to recycle it from that billion-year relic and use it today, there would be zero degradation in quality. Well, not zero, but it would be so minuscule that you shouldn't even acknowledge it. And that's really the beauty of gold, is that it's like infinitely recyclable. But the problem is, it's just recycling it can be so harmful to the environment. And so I believe more solutions should be put in place to recycle gold, because we love gold and we use it for like everything, like electronics. Like we're in the electronic age and even the jewelry age a little bit. So recycling gold is definitely in our best interest. And that was my project. All right, and stop.